So, welcome to this quick problem solve. So this is from the Kangaroo. This is a UK test, like a kind of maths Olympiad. So usually there are two ways that you can solve a maths problem. One is using pure logic, where you sit down and you think and you work through everything to its possible conclusion. The other way, which can be a lot more fun and I think is quite underrated, is just messing around. Okay, what do I mean by that? Messing around. Okay, well, sometimes you understand much more about a problem just by trying things out, seeing whether solutions work, see what parts of them work, see why they might not work, and just trying to play with it as opposed to trying to deduce everything right from the beginning. So that's what we're going to look at today. So let me introduce the problem for you first. The idea is that you have 7 places denoted by circles, and they're connected by lines thus so. Now the idea is that we have to put the numbers 1, 2, 3, 4, 5, 6 and 7 just once into these places such that the sum along any of the lines like that is the same for all of them. If you fancy having a go, please stop the video, try now. So let's have a look at just messing around with this. So the first thing, I'm not even going to think very much. I'm just going to put in the numbers 1, 2, 3, 4, 5, 6, 7. Okay, unlikely to be correct if we add these up. You can see 1, 2 and 5, that would make 8. 1, 4 and 7, that makes 12. It's not right. But now, let's have a look at the first step. Okay, this isn't right, so maybe I would want to get rid of this 2. But this 2 has to go somewhere. Okay, well, maybe I have to swap it with this 6. I don't know. But now we understand that if one changes, another one must change. Well, now this has given us a new perspective. The perspective is that this is really a problem about exchanging the places of numbers. So as opposed to writing them in, I am going to put them on these counters. And I'm going to put these counters in place. And the idea is when I move one of the counters, I'll have to swap it with another one. So I'll put them in here. 1, 2, 3, 4, 5, 6, 7. Now we understand that the problem is really about swapping them round. Right? So now that we understand it's really a problem about swapping around the different ways of putting 7 things in 7 places. So let's try another solution. We know this one didn't work. Let's just try the opposite. Let's try 7, 6, 5, 4, 3, 2, 1. Okay, does this work? 7, 6 add 1, that makes 14. Okay, that's pretty good. 7, 4 add 3, that makes 14. Oh, this looks promising. 7, 5 and 2, that makes 14. But now have a look. 1, 2 and 3 does not make 14. That makes 6. And 6, 5 and 4 makes 15. So these are not the same. We got all the columns correct. Now, let's say we wanted to carry on with this swapping idea. Now we can learn something else. I know that this column here, this diagonal here, adds up to 14. If I swap round this 1 and this 6, it will stay 14. But this will change. This will be 10 and this one will be 11. I still haven't solved it, but we've learned something important. We've learned that when you swap 2 things in the same line, the sum of that line doesn't change, but the sums are the other ones. So it's about swapping things round. Let's see what else we've learned from this. We've learned this cool thing about swapping. We also want to understand, well, why did all these columns all add up to 14? What was so special? Well, let's have a look. 6 and 1, 5 and 2, 4 and 3. These were pairs that added up to the same thing. Unfortunately, this didn't quite work, but it's given us a hint. Let's see if we can use this idea of pairing. Let's go back to the numbers here. So we want pairs that add up to the same quantity. But we understand that we're going to have 3 pairs, so one of them has to go. Well, we've tried 7, that didn't quite work. We could try 1 and then you have 2 and 7, 3 and 6, 4 and 5. But there's this number in the middle in some way. This number here doesn't change. So what number feels like it's in the middle? Well, this is where the intuition kicks in, and it's 4. Okay, so let's try that. See if we put 4 at the top. Now, we need to put some pairs in that will all add up to the same thing. Well, these pairs have to be 7 and 1, 6 and 2, 5 and 3. So let's put this, I don't know, let's do 3 and 5, 6 and 2, and then 1 and 7. Let's have a look. These all add up to make what? Add up to make 12. 4 and 6 are 2, also adds up to make 12. 4, 7 and 1 adds up to make 12. Pretty good, but now, let's have a look. That adds up to make 6, and this adds up to make 18. This one is 6 too small, and this one is 6 too big of the sum we're looking for. We're looking for this. Well, let's go back to what we learned earlier about exchanging things in the same diagonal or in the same row. It won't affect that. So all we need to do is to move things in the vertical. So we need something that needs to get 6 smaller and something that needs to get 6 bigger. Well, which one would it be? Well, 5 and 3, no, they have a difference of 2. 6 and 2 have a difference of 4. 7 and 1, they have a difference of 6. So if I swap these around, then we must know this one has got 6 smaller, it's now 12, and this one has got 6 bigger, it's now 12. And that is how you solve it. I think a lot of math problems are solved using a mixture of logic and a mixture of just messing around, trying things out, seeing what you can learn. In the middle of a math test, sometimes it's actually quicker to do this thing where you learn by figuring things out as you go, as opposed to trying to do everything by logical deduction right from the beginning. I hope that's useful. Bye-bye.